Hey everybody, I'm Brandon Brown. I flew in here early in the morning from Greenville, South Carolina, so if I'm a little bit rambly or tired, that's why. So like Jordan said, I've been programming in Scala for about 6 years. The last couple years really kind of starting to dig more into the functional side of things. And when I first started working at Oseberg, Jordan was like, I task you, that'd be pretty cool if you challenge yourself to present at OKC FP sometime. I was like, yeah, I'll do that. And then I was listening to a podcast where someone was like, well, you know, the best way to give a talk is to pick something that you know absolutely nothing about and then say you're going to do a talk because then you have to learn it. So I was like, you know what? I want to learn about Erlang. Hey, Jordan, I'm going to give a talk on Erlang. And here we are today. So I'm going to kind of briefly, actually, who here has used Erlang before? Sweet. So this is real basic. You don't have to know anything about Erlang. I'm going to kind of do a brief summary of the language, and then I'm going to do some examples. So some context, Erlang was created in 1986 at Ericsson. And the reason it was created was they were migrating the telephone switches off Plex programming, and they needed a new language to program telephone switches. And so basically what they did in the mid-'80s was they said, hey, Joe Armstrong, lead a team, see what languages are out there, and come back to us and say, this is what we're going to use for programming all of our telephone switches. And so as you'd imagine, telephone is pretty big in the 80s. You can't have downtime. So one of the big requirements of the language was you needed to be able to patch code, and there could be zero downtime. And so they did some investigation, and there was some different languages they played around with, but ultimately what they came to the conclusion was there isn't a language for what we want to do, so we're going to make a language. So in 1986, they did the first reference implementation of Erlang, and it was using Prolog as its interpreter. And basically they had everything in-house until the 1998, they actually open sourced the language. And as part of the development, what they did was they developed eventually a virtual machine that the code runs in. So every file is a .erl file, and it compiles down and gets loaded in the VM and run. And what's actually really kind of unique about this is that they built a framework called OTP, which stands for Open Telecom Platform. And it's basically a set of abstractions to help build apps to reduce a lot of boilerplate. And so by the time they actually open sourced this, there was like this whole ecosystem of code that had been tested for like 20 plus years in production working. And in an interview I found online, Joe Armstrong actually said, if Java is the write once, run anywhere, Erlang is the write once, run forever, which is kind of a funny saying. So the general philosophy of Erlang is that everything is a process. Processes, as such, should be strongly isolated, and you should be able to create and destroy processes easily. The only way processes can interact is through message passing. There's no shared state, and in terms of error handling, don't program for all the possible cases. Basically, you want to write your code for what you know is the happy path, and when it blows up, react to it. And because of the way the Erlang virtual machine works, you can actually reload your code live. And basically the way it works is anytime a message is passed, it's running a compiled version of the code. What happens is if you recompile the code, it actually hot loads that in, and on the next time a message is received, the new updated code is picked up. Zero downtime, which is pretty awesome. Originally, when they set out to build the language, it was just internal. They didn't really think about how other people would use it. So it's kind of been this niche language, and one of the places it's actually used in production today is Facebook Messenger is actually built. The backend is all Erlang. So just to give you an idea of like a company that's actually using Erlang. So data types, it's actually really kind of restrictive. There's not a lot. Basically, you have integers, you have floats, you have PIDs, which are references to Erlang processes. You have tuples, lists, maps, strings, which are really just an array of characters. Records are kind of the equivalent to creating a class in any other language. Funds are basically function closures for defining anonymous functions. And then one of the really special things about it is the idea of something called an atom. So an atom is never garbage collected. It's always lowercase. And basically, it's immutable. And it can't hold a value. So it's just kind of like a value class, really. So one of the things that's actually really interesting in Erlang is atoms are always lowercase. Variables always have to be uppercase. Or at least they always have to start with an uppercase character. Which is something that, as I was playing around with this, always kind of bit me. Because I was like, oh, well, I'm just going to not use the shift key. And I'm like, oh, why is that not working? It's actually interesting in a language because the way you terminate statements is with a period. And the way you denote that something is continuing or ongoing is using a semicolon. There's no package structure per se. So like in a language like Java, where you could be like com.brandon.whatever, that doesn't really exist. And you can actually organize your Erlang code in whatever package structure you would want, but basically when you compile it, it compiles it down into basically whatever your working directory is. So you could have like multiple nested deep level file folder paths, and when it compiles down, you just have to say like, hey, this is the file I'm compiling, this is where it is, but it's going to compile it into that directory that you've invoked the shell from. So that's kind of an interesting thing. Module names. So your like .scala or .java file, .js file, your .erl file, whatever it's named, that's the name of your module. So the module that you expose has to have the same name. So there's some built-in kind of like enforcement they do around like standards, and it won't let you deviate from it, which is kind of cool. And then the other kind of guiding principle is that when you do a module, you have to explicitly state what things you want to export. The only thing that I've seen this kind of similar to is in JavaScript, where you can, with ES6, say, export whatever you want. Anything else that you don't export is basically private to that file. You can define macros using this define syntax. They have BIFs, or built-in functions, that have like special reserved meanings. So like VSN will do like version number. So you can actually define in your file version number. And in the shell, you can invoke VSN, and it'll say, this is the version of this module. Another thing that actually really tripped me up when starting to kind of like learn Erlang is I was used to, you could like define variables and things kind of anywhere in your file. That is not something you can do. Any variables that you define have to be within the method, which is actually kind of, at first you're like, why? That's really annoying. But then when you look at it, you're like, actually, this like reduces a whole set of issues that you run into all the time. So it's actually kind of liberating. So the way I kind of wanted to structure this is showing some basic examples, showing the Erlang version, and then showing the Scala version. And so to demonstrate that, I'm going to show pattern matching and recursion, because recursion is a very kind of like core thing in Erlang. And then I was going to show an example of hot loading. So now comes the fun part here, where I try and actually know where my mouse is. OK. So can everyone see my code OK? So what you have here on the left is a simple pattern match. So basically, what we're going to do is define a module. It's called pattern match, and that's the name of the file. I'm going to export a convert length function, which has an arity of 1. It takes 1 argument. I don't define the type of that. I just say, this is the function, and this is how many arguments it takes. this is a pattern match on basically the function convert length takes in a tuple, which is going to be an atom, which can be either centimeters or inch, and then the value that you want to convert. And based on whether you pass in centimeter or inch, it's going to convert the value that you passed in to that format. And the return value is going to be a tuple that is the outbound atom and the outbound value. And so to accomplish the same type of thing in Scala, you basically would kind of do like a trait, case object. You'd have a method that takes in the tuple, and then you do a match on those cases, and then do your conversion. So what takes, 4 lines of Erlang is like 10 lines of Scala, which is actually really interesting. When I started doing this example, the first kind of discovery I had was, wow, I feel like that should be so much easier. And so I'll show you guys now an example of we'll actually compile this Erlang and run it. So I have an Erlang shell. Let's actually make sure I know what directory I'm in. OK, cool. So foreground that. OK, so to compile, I use the built-in C for compile. And all I have to do is pass in the name of the file I'm going to compile. So in this case, it's called pattern match. I don't have to do the extension. And so what I get back as the result of compile is a tuple that is basically was a success and the name of the module that was compiled. So whenever you compile something, that's what you get. So now that I've compiled that module, I will actually be able to invoke that exposed method, which is pattern match, colon, convert length, haha, knew I was going to mess that up. Did I do centimeters? Haha. I never said that spelling was my strong suit. And as a former English major, it's even more hilarious that I can't spell. So you can see I do module name, colon, and then the method I want to invoke, and I pass in that tuple that says centimeters, convert, basically give me back inches, and converts. What's really cool about this is that because everything is immutable, you can define things in the shell, and it doesn't actually let you redefine them. So as an example, I'm going to say that f is equal to foo, the period. And so now I can do f, period. It's foo. If I try and say that's something else, it's not going to let me do that, which is actually like one of my favorite things as I've played with Erlang is that it does not let you redefine variables. It is completely immutable. So if I wanted to say I was experimenting with something and I actually want to free up that variable, instead of closing the shell, I can just do the f built-in, which basically invokes a flush function. And so it's cleared, and now if I try and cast it to Jordan, it'll let me. It lets me. So I thought that was actually kind of like a really interesting thing that I was never used to, that normally when you're working within a REPL, you can redefine things all willy-nilly. It doesn't punish you for that. And I was like, actually, I kind of like that it punishes me for that. Because it really, Erlang, every step of the way, hammers into immutability. So I thought that was a really fun thing in this language. So pattern match, what you can see here is basically we just define each of the cases And all I have to do is, if I were to add another case, for example, I would just replace that period with a semicolon and then put the next case match in and make sure that whatever your last statement is has to terminate with a period so it knows that's the end. So that's kind of the basic of one way of doing pattern matching. So now recursion. Actually, I forgot I already had it up. So now recursion, factorials, our building block. So to define factorial in Erlang, it is 2 lines. Fac. So I use this as an example because this is a specific place where you can see where that whole like module naming thing kind of starts to become a little bit of a pain in the butt. Because if I want to invoke this function, then by default I would have to say factorial colon fac and then the value. I can cast the module to a variable to shorten that up, but one of the things that Erlang kind of strongly discourages against is renaming whatever you import. It actually really wants you to invoke everything by the fully qualified module name. And the main reason for that is there's a rich set of built-in functions, and because of the lack of like packaging like there is in other languages, they want it to be explicitly clear to the programmer, this is what version of something you're using, and this is where it comes from. So that's actually another thing that I thought was kind of interesting as I started to dig into Erlang a little bit is you can very easily, as you look through people's source code, see, oh, this is where they're using something that's built in, or this is a third party or something that they've defined. You get that built in just by reading the code. So the fun thing, because it's magical, hot loading. Because this is actually really the whole reason I did this talk was I wanted to actually see this in action. Okay, so what I'm going to do here is I have a simple pricing service. So I'll go to the top of this file and kind of walk through what it's doing. So we have, we're going to link it to a process, and that makes it so I can actually send it messages. This little thing where it says spawn link question module, that's effectively the same thing as if I were to pass in place of module the name of the file. So this is kind of like this shorthand thing where Erlang can automatically know what the name of the module is. So if you were to like rename this file, if you use that $module, it's not going to blow things up because it knows the actual name of the module. We have our message receiver, which is going to take a request and basically invoke the handle of the request. And then basically, after it's processed that request, loop back on itself and basically wait for the next message. And so handle request is going to take in a request, and in the case that I pass it in version as an atom, it's going to return the version of the module that's running. And if I pass in a tuple that is price and the item I want to know the price of, then it's going to invoke this function call to look up that item and say, hey, this is how much that item costs. So reply with version. Anyone that's used Akka before will be familiar with the tell bang sign. So we're saying, hey, tell whatever the client is that sent the message, tell them back this is what the version is. And in the case of reply with price, it's going to do this nice little IO format where it's basically just going to print out the price of the item is, and it calls this method to get it, where you see yet another version of pattern matching. So there's kind of this pattern matching within the context of like a function, and then there's pattern matching on like values for lookup. So these are basically two ways that you can do what's known as pattern matching in Erlang. And so all I'm saying is, well, if it's tea, it's this much, and bread and milk. So if we go ahead here, and my eyesight is also really not good, so this is really funny. Okay, so I'm going to compile pricing service. So I know I did something wrong there. Let's start that again. Yep, okay. Oh, because I did it in quotes. Okay, so this is actually another thing that really tripped me up in Erlang is you don't have to quote the module name unless it's not in that directory. So if it's in another directory, then you have to quote it. Yes, effectively is an atom. The question was, is that an atom? So I've compiled my service. So I now have a .beam file, which is compiled. And so now what I'm going to do is create a variable that's going to basically spawn that service that I can then send messages to. So I'm going to call it service. Set equal to pricing service. And I call link with. And I just do self. And so that is the process ID of this process that I've now spawned, is 82. And there's some things where you can actually monitor processes based off of their specific PID. So now that I have service, I can send it a message, and our two messages were version or the tuple. So I'll do service, bang version, and it returns to me service version is 1.0.0. And if I say service price milk, it's going to say, hey, the price of milk is 99 cents. And let's just do something that doesn't exist, so you can see it blow up. It's not happy because that entry is not in there. And now you notice if I try and send it the message milk, it returned nothing. That's because that process has died. Doesn't exist anymore. So what I'm going to do here is I'm going to flush out what I did, and we'll recreate our service. So we've respawned it, now has a PID of 90. And now what we're actually going to do is change our code. That's what happens when it's not happy with me. Maybe come back. There we go. Okay, so I have gone ahead, and I'll just get that guy out. So we have milk, we've now bread, granola. So I'm also going to go ahead and be a good citizen here, and I'm going to increment my version. So now I'm going to go ahead and we're going to send the version message. And remember, when I compiled it, it was version 1.0. I'm going to recompile it. I've recompiled, and now when I say version 1.0.0, 0 downtime. And now I can say, hey, granola, and it works. So that was pretty magical to me, still. But I didn't have to restart the shell. It just actually basically picked up that code change. If there's a scenario where the compiled code is actually in a different location for some reason, there's actually, I think it's RR is the built-in function for reload, and you can actually pass in the path to the module, and then it will do basically the same thing that it kind of auto-discovered. And there's actually a whole set of things for actually managing versions and helping like roll out new versions. There's something called rebar that basically like lets you define kind of like a change log file that's like the evolutions of script changes to happen, and it will actually manage like applying those changes and error out if they don't work. That was something I actually like just started reading up on recently. Jordan. So the question was, can you push this out async while the current module is doing work? And the answer is yes. So basically, you can push out the recompiled code on, say you had 10 nodes. And basically what would happen is, say you pushed out to those 10 nodes, the next time that the method is invoked, it will execute the newest version of that code. So effectively, because everything's a message and is passed, you basically have this small window of when you're deploying out the code where someone might get, an old version of the function, but then the next time they call the service, they would get the updated one. So yeah, I thought that was like pretty fascinating.
What happens if you were in this module to remove the definition of the service itself and then try to crosswalk it when you already have a service defined?
If you do that, I haven't tried this. So the question is, if you were to say like nuke out the service and recompile it and deploy it, what would happen? I haven't actually done that, but just based off of experiences, I think what would actually happen is it would try and invoke the method, or try and pass the message, and what would happen is it would get a response back that the message is not defined, and so it would just actually blow up the process. So the question is it atomic? So if you have like a chain of function calls, will it honor that? So the way it works, yeah. Yeah, so it'll basically, if nothing changes in the downstream, in like say you just changed one method call, but you didn't change the downstream method calls, it's only going to affect the reception of that first message. But it's because the load time is like so small, the number of messages that theoretically would like process the wrong thing downstream is going to be pretty isolated. Because the amount of time that it takes to reload that new version is pretty small. But I don't think it is completely atomic. There is going to be that little loss gap. Yeah, so I mean, effectively, you can, in your downstream functions, have, programmed, I only will accept this version of a module to kind of like ensure that it only follows one specific path. Again, the whole idea is you're only coding your happy path. So if you encounter something that's breaking, you kind of want to basically effectively not keep like duplicate code paths. You want to just replace that broken code path and let the subsequent messages be processed correctly. And just kind of say, you know what, it's okay if a couple messages get processed wrong. So the example that you'll see with like telecom switches is, okay, someone goes to make a call. Well, it's okay if the call doesn't go through. You'll try again. And in terms of like the end user like frustration, it's pretty small for them to like try a call again. And probably in the time that it took them to like redial an extension, it's been deployed out and working again. And again, because Erlang is built all around the concept of distributed systems, hopefully like your messages are balancing across nodes such that it's very few people that will experience that, like, oh no, my call didn't go through, as an example.
Yeah, it seems like it'd be well fit for TCP/IP connections then too, because the actual likely loss of a couple packets is pretty significant since they're going to auto request anyway. What's the performance of this? I mean, how's it compare to something like Go all the way up to JavaScript and Ruby or Python or anything else?
So the question is, what is the performance characteristics of this network communication-wise as compared to something like a Go or Ruby, Java? That I actually don't know the answer of, but I would think it's comparable, if not slightly better, because it's all of the kind of like underlying built-in things they have around networking have had like years of kind of like battle testing through that. But I would say it's at least comparable, but I don't know 100% sure. I have an example of that. If I actually go back to my PowerPoint. Okay, so it's kind of like recap. Everything is a process in Erlang. And whenever you hear the word process in Erlang, it's an actor. That's what it is. It is based down to this single thing that receives a message and does something with the message. And basically, there's one of three things you can do. You can create a new process. You can send messages to other processes. You could designate what to do on the next message. You could, theoretically, if it were to die, say, hey, what do you do in the case that catastrophic failure happens? So to show an example of that, what better than a game of Russian roulette? So what I'm going to show you guys is two modules. One that's going to be called Doctor. Doctor is going to act as like the monitor. And Roulette's going to be the server. That's actually the game instance. And then the client's going to be the console. And basically, what I'm going to do is I'm going to start up the game, and I'll send it a number. And based on the number I send it, it'll either say click, or when I send it the number, I think 3, it'll say bang, you're dead. And then, instead of blowing up completely, it's actually going to spawn the game anew. So, to do that, okay, so let me. Let's get some more space here. Okay, so this is the doctor. By convention, he has a method called loop. And this process flag, trap exit true, is what makes it so that in this loop method, I can say what to do when things blow up. So the happy path is I send it a new message, and it's going to register a process with the name revolver, and that is going to spawn a process, which is the Roulette module's loop method. And so then by saying register revolver, what I will be able to do is say revolver tell the number, and it'll pass that message along. Because I've specifically here said that revolver is the atom that I'm going to reference this guy by to send messages to. And once it gets a message, it's going to process that message and then call loop and go back around and wait for the next message. Now, the next fun part is this trap exit. So because I put that process trap exit, I now have to code in this path that says when an exit message is received, and it's going to be a tuple that's going to be exit, the from, and the reason why, what do I do? And in this case, I'm going to say, hey, shooter died. This is why I died. I'm restarting. And all I'm doing is I'm telling self.new, create myself a new. And so basically what will happen is it'll just kind of keep restarting itself. It won't die. And then to show you guys what Roulette looks like. So Roulette is real simple. It receives a number. In this case, it receives 3. It says exit Roulette, die at the time we're dead. And if you do any other number, click. This, so I didn't come up with this example. This is actually from Bruce Tate's book, 7 Languages in 7 Weeks. This is actually the example that he uses to illustrate Erlang processes. And there was something about it that was beautifully simple, and I felt really encapsulated the idea of here's this thing that you're starting, you're killing it, and it's starting it anew, and it's very clear. So it's not my morbid fascination or anything. So we're going to go ahead and compile that. Now this is under a code path, under a folder. So let's say doctor. And then we also have to compile roulette. Okay, so we've compiled our 2 modules. This is actually one thing that kind of was frustrating in Erlang, as I did not find a way that you could pass an array of modules that you want to compile. You have to kind of do them one by one. Maybe there is a way to do that, but I didn't find that. So what I'm going to do is I'm going to create a variable doc, and I'm going to set it equal to, I'm going to spawn a function. And so here's that fun anonymous closure. And it's going to be the doctor loop and the arity, which is 0 because it doesn't take any arguments. So I've created a doctor, and now I can say new. So creating and monitoring process. And so now, because I registered that process with the atom revolver, if I want to play the game, I say revolver bang 1. Ah, yeah. See, that spelling thing again. There we go. Bang, click. So we can go ahead, we could say 5, click. And so now I'm going to kill it with 3. And we see the shooter, who has a process ID of 112. He died at that specific time, and we are restarting. And so now, check this out. Click. So you can kill the doctor. What I did not figure out is, because I set in that trap exit, I have not found out when you set trap exit how you forcibly actually kill the process. I I know there's a way to do it, but because I have that trap exit, I think there's something else that you actually have to put in to make it handle the case where you actually really do want to kill that guy. Yeah. Basically, if you try and explicitly pass the exit status with that guy, it's not going to match the pattern match, and so it doesn't do what you really want it to, which is forcibly die. So now the last thing I want to show you guys. So Erlang is all about distributed computing. You should be able to send remote message remotely to various nodes. So what you see here is a picture of a Raspberry Pi. Ignore, Alex, please, the terrible cable management. But that is my Raspberry Pi white noise. So at the company I worked at before, we were working on one of the projects we worked on was basically creating a poller for devices like a Raspberry Pi that could poll various IoT devices and report back a message in our kind of standardized payload. And so because I had an office that I went into and my Raspberry Pi was at home where all my devices were, it was a real pain in the butt to have to drive back to my house just to like, if I didn't want to run the poller or I wanted to like update to the latest version of code to actually test it out. So what I did was I used a open source package called PiVPN, which basically lets you create a VPN server with your Pi. So I am currently connected here in Oklahoma City to that Raspberry Pi. And what I'm going to do is I'm going to do a simple ping pong game with Erlang, and I'm going to do the same thing with Akka Remote. So the basic principle of this is I have the code out on the Pi, and I have it also locally on my laptop. I'm going to start the Erlang shell with a name, which basically makes it identifiable and allows other Erlang processes that, as long as they can communicate to that node, to pass messages to it. So the Pi is available on 192.168.122. And so I'll start it with the name Pong at that IP. And then I'm going to invoke remote Pong start Pong. And basically what it's going to do is it's going to sit there and it's going to wait until I send it a ping message. And then it's going to Pong back to me. And the way I'm going to send it the ping message is I'm going to start an Erlang shell on the laptop, but the @ is going to be my local laptop's IP address. And because I'm on a VPN to my house, they can see each other and talk happily. And what I did is I set it up so that if I just pass in a tuple with the address to communicate to, it will do it 5 times. Or optionally, I can pass in a number, which is the number of ping pongs to basically go back and forth. So, for this, because a little bit easier. Okay, so. So I'm going to kill that guy. Get ourselves a little bit more screen real estate here. I'm a sound nerd, so that's why I decided to name this guy White Noise. So here I am. I'm going to go into the Erlang directory. And let me just, okay, make this run a little bit faster. So I've started the Erlang shell with that name. I can now compile my module. And I can now say start. Responds true. And so now it's just listening, waiting. I'm also really bad with this MacBook keyboard. Those quotes. I'll get you every time. You see? I wish it just was blown up, but. There we go. Haha, success. And so now, it did it, but if I try and do it again, nothing's going to happen. And that's because that process on the server is dead, so I'd actually have to restart it. So I'll go ahead and I'll start him again. And now we'll pass in, we'll say 10. Can do it 10 times. And the code to accomplish this so you all control me on my Emacs. Oops. So in order to actually accomplish this, I actually have to put a cookie file on all the nodes that are going to be communicated with, and they have to have the same contents so that you basically can allow the communication. And then, like I said, it's just a matter of actually passing in the explicit name and IP address that's discoverable on, or fully qualified domain name that can be discovered on. Otherwise, if you don't provide that, it expects that it's discoverable on the same network binding. So to define this, I just said, basically, hey, ping pong, what to do. When you set a ping, say, hey, ping received. Or sorry, when you send pong to ping, it says, hey, ping received, and vice versa. And it basically, what it's doing is continuing to recursively call itself based on the number that's passed in. And it's just counting it down. So every time it gets the message, it basically sends the new value. It's not modifying any state at all. It's just changing that number down, recursively calling itself back and forth until it's done. So the last example that I have here was Akka Remote. So Akka Remote is actually kind of cool in that it basically lets you do actor communication using TCP. And what's actually really awesome about it is only the actors can actually communicate with each other, and they have to be the same version of the Akka Remote Actor library. If they're not the same version, you'll actually get a version mismatch error when you send a message to it. And I actually tested this. I tried from Erlang, opening up a TCP connection and sending it a message. And the message was received by the remote actor, and it was like, I don't know what to do with this. So there's a serialization step that Akka does to basically keep the communication secure, which was kind of cool. So to do that, we're going to go ahead and so I use this thing called warp directory, and it basically lets you define warp points, and then you can just do WD, the name of the point, and it'll jump to where it is on the file system, which is really fun. So I'm going to go ahead and start this guy up on the remote. And this is effectively the same thing. The only difference is that this guy is going to actually initially send, my local laptop's initially going to send a who am I message, and basically both machines will echo out files and operating system properties so that you can fully believe that I'm not duping you, that it's really that Pi that's in South Carolina. So and so here I basically have two different classes, one that's remote actor and one that's local actor. They both are taking in configuration files that tell it how to communicate. And so you can see I'm just basically echoing back the message, hello from remote actor, and the time. And you can see, if I scroll up a little bit, where it's printing out some system profile information here of the local computer versus the Raspberry Pi, Linux. So the last thing I kind of wanted to talk about real quickly, and I have a GitHub repo that has all this code. So Erlang, as they were doing the development, they created this framework called OTP, Open Telecom Platform. And basically, it provides a set of generalized abstractions for how to basically create distributed messaging systems. And so just like with Akka Actors, where you basically just have to implement the receive method, there's that same type of thing built in for Erlang via OTP, but it's packaged with the language. So when you have the Erlang compiler installed on your system, you have the OTP framework at your disposal. You don't have to add it as this third-party library. It's just there for you. And it basically provides abstractions for supervising processes, creating state machines, event handling, and it all works around the idea of like you basically define like behaviors and then implement the contract, which is for the most part basically kind of like a receive method. And so I have actually the code for that out on my GitHub that I pushed this morning. Are there any questions? So one final thing I would say is diving into Erlang, one of the things that was kind of interesting to me was initially I thought not having a type system would be like really frustrating. And what I realized is the types of problems that you're trying to solve with a language like Erlang aren't crippled by the lack of a type system, because you're basically trying to boil everything down into these like really simplified use cases that don't require elaborate type systems. And that was kind of a big eye-opening thing for me, the language. So thank you guys.